A little bit about what Kit.com is. We're a user-facing consumer website. We launched about a year and a half ago, and our site, our premise is that the best way to find products worth getting is from people you know, people in communities you're a part of, or experts that you trust. And so at Kit.com, anybody can go online and make kits of the products that they recommend for different activities or things that they use for their daily life. Because of this, our content is entirely user-generated and dynamically changing throughout the day. So it poses some interesting challenges for analytics. It's not a static website that the same link is going to be in the same place at different times. And we generate millions of user events per day. And this infrastructure is kind of how we're handling that data and how we're gaining product insight from it. So when we launched, we looked like this, and this is probably a pretty familiar diagram to a lot of people. Our production database is on RDS, Postgres. We have application servers that access that data. That's hosted on Opsworks, and web clients hit that API, and then also have the out-of-the-box Google Analytics snippet that is just sending page view data to Google Analytics. And when you launch, this is great. You get a rough idea of how many people are on your site at any given time, what pages people are on, but it's not really possible to link that data to your production application data. So it's not really very full-featured for measuring dynamic content or interactions like that. And so what I'm going to walk you through is kind of the steps we took at various times in our growth cycle that we've augmented our infrastructure. So our next step looked like this. We started using a dashboard product called Metabase, which you can host on Elastic Beanstalk. And it's a way to get insights out of your data. One thing that we found really valuable is we actually replicate our events between Google Analytics, Intercom and Mixpanel, any other external services, and our internal eventing tool. So we're using the exact same event nomenclature for any service we're on. We found that to be really valuable for no matter who's looking at your data for business intelligence, they're using the same language no matter what platform they're on. A few things here that you can capture in different areas that we found to be useful. When you're capturing when you're capturing events from your JavaScript and replicating them here, you can also capture interesting stuff from the client browser that might be useful for tracking later, screen resolution, operating system, various things like that. However, I recommend capturing things like timestamp on the application side. This is something we were originally doing on the client side and found huge variance with people having their clock set wrong. It threw off all of our data, so that's just a tip for you. And then you can also capture the IP address at the application side for geolocation, stuff like that. And this is kind of something that if you're coming from an enterprise, this diagram might look strange because we are reading off of the production database. That's very scary. But at a startup, these are the kind of trade-offs that you're going to be making. Basically for cost and simplicity, this might work for a good amount of time. However, our next stage was to move the read traffic off of our production database, and read replicas in AWS RDS are super easy to set up. So for a while we were just running a read replica and running all of our dashboards off that. It's nearly live data. So also this was a great, this helped us scale for a while. Oh, yeah.
This might be a dumb question, but what are the drawbacks to reading straight off the production database for dashboards?
The drawbacks here, mostly that you just don't want to have too much, basically just to keep your traffic off of your production database as much as possible, depending on how you're set up. Obviously, this is a really simplified diagram, but we're also using Redis caching to keep traffic off of our production database. But just so that if there are any very complex queries you're writing that might lock certain tables, it's just a safer practice. But that is a good question because it's different for every application and kind of one of the technical considerations I'll go into later. But depending on how your traffic is or how much, in our case we have a lot of write traffic because people are constantly creating these kits. So it was something we were very concerned with, but it might not be a concern for every application. But that's a great question. So this got us up to a certain point just to keep our traffic off the production database. As your events start to grow, though, you're still going to start to need to get to shape your data in ways that are easy to query for these dashboards. And the next thing we introduced was an ETL job that would kind of transform our data aggregated along interesting facets like user ID, dates, so we can start calculating more complex queries like daily active users, monthly active users, things that were starting to get very slow in just raw queries against our production database joined to our application database. And then the next step even beyond that, and this was kind of where we've moved to now, is to introduce kind of two of the newer pieces of AWS infrastructure. One is DMS, the Data Migration Service, which is I think a fairly new service from AWS that helps you replicate your data from Postgres into Redshift. And Redshift is a super powerful analytics platform. Cost-wise, it's actually about the same as the read replica, and it can return data. I think they quote that some queries can be improved by about 200x if you set up your Redshift properly. And I'm going to go into some of the implementation details there as well. Yes?
Sorry, can you talk about as you're going through this,
Sure.
your timeline? If you have the information, can you talk about when, like at what points you saw the need to make these migrations?
Yeah, absolutely.
Volume or usage?
Yeah.
Or
Let me think about that. So I think this was more, I think about the query time. And again, it's hard to say about volume and usage because it really depends on how many events you're sending per user, depending on how many interactions users take. So it's kind of hard to say. I will say that like what was happening, the reason that really motivated this specific change for us is that our dashboards were taking about 5 minutes to load. They were just certain queries, like the way we were joining across many tables and aggregating. So Redshift does something called Columnar Storage, and so it lets you basically, it optimizes the type of data that's being selected out, and we saw massive improvements. Like we had a MAU query that took 7 minutes to run on the read replica, and it took 7 seconds after we moved to Redshift. So it was very powerful. You do have to do some work to customize Redshift to get it there. So the answer isn't really about like volume or load, it's really going to be about the types of queries you run. That's kind of, when it's too slow, that's when I would recommend looking at Redshift. Yeah. Yeah. And then kind of, this is what our infrastructure looks like pretty much now. And kind of, I didn't want to say what I think our next step will be. And this is probably closer to what an enterprise eventing solution will look like. And that's moving the event capture entirely to a parallel stream from the production database. And so this dotted line is kind of that aspirational track here. It would look something more like a traditional microservices architecture that you'd see at a large company. And the eventing database or repository might be Kinesis or a stream like that. That's really kind of where I would see us going. And again, that would be just to keep as much traffic out of the production database as possible with that consideration. I do have some notes kind of if people are looking to go this route and to build in that direction, to cover some of the implementation considerations I think have actually been touched on. You do want to think about what your event hierarchy is and how granular you want those events to be. You want to make, the way that we think about them is if we had this data, what business decisions would we be able to make 3 weeks from now if we had perfect insight into that data. And so that's going to shape how many events you're storing and really how you're aggregating this data in the future and what kind of infrastructure you'll need for it. You also always need to be thinking about, like I said, how you're joining between your web app stats and your analytics stats. That might be storing your analytics data and your application data together for a short period of time if that makes sense for your startup. Or it might be, as I showed, a completely parallel process where you have a migration service that they can both live together in one warehouse or analytics platform. The last thing is more just operationally. I highly recommend that you track your event changes very well over time. You want to make sure that the events you're capturing today are useful for a business analyst that's going to join your company a year and a half from now, that they understand why this type of event went up or went down because if there was a change to your eventing strategy. And so I think that is just a good operational note. 2 tips on the AWS specific elements I talked about at the end, and that's DMS and Redshift. I put these tips here because they were new to us and I thought they might be interesting to people implementing this type of solution. One, when I mentioned DMS to a lot of people knew it for one-time copying of data, and it has a great setting for replicating ongoing changes, and that is really what powers our analytics platform. It keeps it pretty much a real-time feed of changes into our Redshift database. So there's pretty much no noticeable latency there. Using DMS, you will find the need for some small schema conversions to be aware of. If you're using newer Postgres constructs like JSON objects or arrays, those will have to be cast as strings. We also found that to be true for Booleans as well. We just couldn't get the schema migration to work properly with that. With Redshift, I kind of touched on some of these benefits here. The things that will really make the Redshift analytics platform very performant are columnar storage. So when you're pulling queries out, unlike a Postgres database, you're not pulling out whole rows. It's actually just getting exactly the data, the items that it needs. And so optimizing your queries for that, to take that into account, really will improve performance. It leverages compression. You don't need to do much to do that, but that's one of the reasons why it gets such great performance. And then it also supports parallel execution, so you can run multiple nodes. You're going to want to groom your schema to contain sort keys and disk keys. These are two Redshift-specific constructs. A sort key, in our case, would be like a timestamp for our eventing table, just like logical groupings of data that you're going to be commonly sorting by. And then disk keys, again, really only matters with the parallel execution. It's kind of like, it just ensures that those IDs might be grouped on the same node. So you might use user ID for that. I feel like I had another tip that was cut off on this slide, but I can't remember what it was. Cool. So like I mentioned, this really helped us kind of just in numbers-wise. Like I said, this took one of our most complicated calculations down from about 7 minutes to 7 seconds. And just more qualitatively, like having fast access to dashboards of our numbers and really giving that power to our whole team really gave us all confidence in those numbers and really made it really easy to communicate our product's performance and the direction of our product to both within the company and externally to investors and to other people that might be interested. Cool. So with that, I'd like to open it up to questions.